Here we go.
Julian, we are live.
Hi, everyone. A very warm welcome to this session of our older youth group as our webinar. And we, as every other week, we come with our older youth group on Saturdays and our younger youth group who goes live every other Fridays. So we are extremely glad to bring a new topic each week. And this week we have with us four panelists who are not only they are passionate about the webinar, but they always, even if they have tons of work at school, but they never miss to be in this webinar, share their ideas, work for the topic that they choose. For this week, they have chosen the topic rocket programs and missions and programs important to space history, and that were revolutionary, that took men to moon and rovers to Mars. So today's topic is with space rovers rockets. If you have joined in on YouTube or Facebook, please join in our Zoom link so that you can interact with the panelists and we can share our knowledge and ideas. So with that, over to you, Veda, Vivan, Virat, and Vish. And there you go.
Thank you, Jalanti, for the introduction. Hi, I'm Veda, and I will be one of the moderators for this week's webinar. And the topic is rocket programs. Next slide.
Hello everyone, I'm Vish, and in this week's webinar, I'll be talking about Polaris and Starlink, two space programs, rocket programs made by SpaceX. And sorry about forgetting my picture.
Oh wait, could you refresh the slide deck?
I'm not sharing my screen. I think Vish is.
Oh,
Got it.
Oh yeah. Sorry for that.
And refresh. Now let's share. What's different?
You can continue.
You never did your intro.
It's your intro.
Vivan.
Sorry, Zoom isn't working for me. But okay. Hello everyone, my name is Vivon, and I will be talking about the Voyager and Mariner program. The Voyager only consists of 2 spacecraft, and the Mariner consists of 10. They're all interplanetary or interstellar probes that were meant to explore places beyond Earth.
Next slide. Hi, I'm Veda, and I will be talking about the space programs Gemini and Skylab, which were both created by NASA.
Hello, I'm Virat, and I decided to go with the Artemis program and the Apollo program. I'll tell you why they're named that way.
First, we'll be doing Meet the Panelists, and then they'll tell about their about the topics that they chose, and then we'll do Q&A. Next slide. One small step for man, one giant leap for mankind. A quote by Neil Armstrong. Could you refresh the slide deck? Next slide. Gemini and Skylab. I will be talking about Gemini and Skylab. Next, Gemini was NASA's second human space flight program. It was conducted between projects Mercury and Apollo. Gemini started in 1961 and concluded in 1966. The purpose of Gemini was to crew orbital flight and extravehicular activity, rendezvous, and docking. The Gemini spacecraft carried a 2-astronaut crew. 10 Gemini crews and 16 individual astronauts flew low Earth orbit missions during 1965 and 1966. Next slide. Oh wait, can you go back? I forgot to do Skylab. The launch date of Skylab was on May 14th, 1973. It ended on July 11th, 1979, when the spacecraft crashed and burned. The purpose of Skylab was to provide an outpost in low Earth orbit when astronauts could learn to adapt to life in space and to live and work outside the Earth in the microgravity environment. Next slide. Gemini's objective was the development of space travel techniques to support the Apollo mission and land astronauts on the moon. In doing so, it allowed the United States to catch up and overcome the lead in human spaceflight capability the Soviet Union had obtained in the early years of the space race, demonstrating mission endurance for just under 14 days longer than the 8 days required for a round trip to the moon. Methods of performing extravehicular activity without tiring, and the orbital maneuvers necessary to achieve rendezvous docking with another spacecraft. This left Apollo free to pursue its prime mission without spending time developing these techniques. All Gemini flights were launched from Launch Complex at Cape Kennedy Air Force Station in Florida. As you can see, there's an image over there on the screen where it says Gemini. That was the Gemini spacecraft. Vish, you're on the wrong slide. Can you go back a slide?
Got it.
Their launch vehicle was the Gemini Titan II, a modified intercontinental ballistic missile. Gemini was the first program to use the newly built Mission Control Center at the Houston Manned Spacecraft Center for Flight Control. The astronaut corps that supported Project Gemini during Mercury 7, the New 9, and the 1963 astronaut class. During the program, 3 astronauts died in the air crashes during training, including both members of the prime crew for Gemini 9. This mission was flown by the backup crew. Gemini was robust enough that the United States Air Force planned to use it for the Manned Orbital Laboratory program, which was later canceled. Gemini's chief designer, Jim Chamberlain, also made detailed plans for cislunar and lunar landing missions in the late 1961. He believed Gemini spacecraft could fly in lunar operations before Project Apollo and cost less. NASA's administration did not approve those plans. In 1969, McDonnell Douglas proposed a big Gemini that could have been used to shuttle up to 12 astronauts to the planned space stations in the Apollo applications program. The only applications program funded was Skylab, which I will also be talking about later, which used existing spacecraft and hardware, thereby eliminating the need for big Gemini. Now I will be talking about Skylab. Skylab was the first United States space station launched by NASA. It occupied for about 24 weeks between May 1973 and February 1974. It was operated by 3 separate astronaut crews, Skylab 2, Skylab 3, and Skylab 4. Major operations included an orbital workshop, a solar observatory, Earth observation, and hundreds of experiments, unable to be boosted by the space shuttle, which was not ready until 1981. Skylab's orbit eventually decayed and it disintegrated in the atmosphere on July 11, 1979, scattering debris all across the Indian Ocean and Western Australia. NASA management was concerned about losing 400,000 workers involved in Apollo after the landing of the moon in 1969. A reason von Braun, head of NASA's Marshall Space Flight Center during the 1960s, advocated for a smaller station after his large one was not built. He wishes provide his employees work between developing Saturn rockets, which would be completed relatively during Project Artemis. NASA set up the Apollo Logistics Support System Office, originally intended to study various modified Apollo hardware for scientist mission, but instead this office was used for the development of Skylab. The office was initially proposed a number of projects during the direct scientific study, including an extended stay lunar mission with required 2 Saturn V launches and based on the lunar ML module. A crew from this office was working on the Skylab project from there. Thank you for listening to my presentation about the space programs Gemini and Skylab, which was both conducted by NASA.
Hello, everyone. Like I said, I'll be talking about Polaris and Starlink. Both the programs, Polaris and Starlink, were developed by the private company SpaceX. And many of you probably know what SpaceX is. Even though they were both created by SpaceX, they both served a very different purpose. So let's check it out. First up, we have Starlink. Starlink is the name of a satellite network developed by SpaceX to provide low-cost internet to remote locations. SpaceX hopes to have a bunch of satellites in the so-called mega constellation. Starlink is on the leading edge on orbit debris mitigation, meeting or exceeding all regulatory industry standards. At the end of life, the satellites will utilize their onboard propulsion system to deorbit over the course of a few months. In the unlikely event the propulsion system becomes inoperable, the satellites will burn up in Earth's atmosphere within 1 to 5 years, significantly less than hundreds or thousands of years at higher altitudes. Starlink internet works by sending information through the vacuum of space, where it travels much faster than the fiber optic cable and can reach far more people and places. Well, most satellite internet services today come from a single geostationary satellite that orbit the planet around 35,000 kilometers. Starlink is a constellation of multiple satellites that orbit the planet much closer to Earth at about 550 kilometers and cover the entire globe. Now you'd ask, how does Starlink send such fast signals? Starlink satellites use a thing called an optical space laser, which allows it to transmit data without the need of local ground stations. Because Starlink satellites are in a low orbit, the round-trip data time between the user and the satellite, also known as latency, is much lower than with the satellites in geostationary orbit. This enables Starlink to deliver services like online gaming that are usually not possible on other satellite broadband systems. Low propulsion system. Ion propulsion systems allow Starlink to orbit, raise, and deorbit at the end of its life. This makes it the first ever krypton-powered spacecraft. And that's it for Starlink. Now let's move on to Polaris. Polaris' full name is Polaris Dawn, and it is a human space flight to orbit Earth with only private citizens on board. The crew consisted of Jared Isaacman, Scott Pitote, Sarah Gillis, and Anna Menon, who will spend the first 5 days in orbit. Because Isaacman previously flew onboard Inspiration 4, he will become the first person to fly onboard Crew Dragon, which is a crew, as you can tell, multiple times. Mission plans include reaching an orbit higher than any previous Dragon missions, and ultimately the highest Earth orbit ever flown with the initial apogee of 1,400 kilometers, breaking the record set by Gemini 11. Polaris Dawn will conduct research on the effects of space flight and space radiation on human health. The crew will also attempt the first commercial extravehicular activity, EVA, with SpaceX designed EVA suits. The mission will also be the first test of Starlink's communications lasers for communication with another spacecraft, potentially improving connection with the spacecraft. The first SpaceX mission launched on Valentine's Day was the first of 3 to be launched, the other 2 of which haven't been launched yet. Now, that's it for Starlink and Polaris, but before it's over, here's some fun facts. The SpaceX Raptor engines are half as hot as the sun. And second, the under development helical engines are believed and said to be able to go close to the speed of light, which would mean that you could reach the moon in 1.3 seconds and Neptune in possibly 3 hours. And finally, helical engines don't need fuel at all. All they use is a spring, which will create propulsion, which is needed to make the spaceship move through space. And now, that's it for mine. Now moving on.
That was really interesting there.
Could you refresh the slides?
Who's doing the moon?
I am.
Okay.
Wait, before
It's
you go,
interesting to know the helical engines don't use any fuel, since their springs they require electricity, don't they? Okay, here we go. The moon. The moon has been a big target and it has been seen since the dawn of humanity. It has been seen, even it might have been seen before the sun, or it might have been seen after the sun. We don't exactly know which one was seen first, but whatever it was, this was one of the first things to be discovered in astronomy by human beings. It's such a bright thing in the sky, and it's almost impossible to miss on a clear night sky. So, here we go. Next slide. Rish, next slide. Hello? Rish.
It's fine. I think he froze.
Okay. I'll share my screen then.
Okay.
Guys, what's the problem?
Oh, you weren't responding.
Oh, sorry. The thing froze for a second.
Okay.
Wait, why are you skipping my slides? What?
So, the moon.
I'm just
The
skipping my
moon. Um, we're not doing mine. The moon. It has been a target since the dawn of humanity. It's one of the first things that has ever been seen, and the first thing to be discovered by astronomy, apart from the sun, of course. Next slide. I got the slides. Okay. Apollo and Artemis. These programs are sister programs, and they're also sibling gods. Apollo and Artemis both share the ability to spread plagues to mortals, and Apollo and Artemis both share the goal to send people back to the moon. Well, the first statement was about the Greek gods, and the second statement was about the NASA programs. How fun is that? So, both of the gods and the programs do share something in common, a goal and an ability. So the Apollo program was meant to send people to the moon, and overall the US government has spent more than $250 billion into the Apollo program since the 1960s. And all until Apollo 11, they were just practicing, like all the way from Apollo 1 to the Apollo 10. They were practicing on getting to the moon, and they were just getting better every single time. And all the way until Apollo 17, it kept running quite fine, and there was actually only one partial failure. Apollo 13. Apollo 13 had a burst liquid fuel tank, and thanks to the very clever engineers of the NASA team and the very cooperative team at Apollo 13, they were able to safely bring back everyone from the Apollo 13, even though they had a bust oxygen tank. And since they didn't get to the moon, they called it a successful failure. Now, Artemis has the plan of sending people to the moon and beyond. And one thing to note here is that Artemis program, the main part of it consists of the SLS, SLS-1A, SLS-1B, and then the different blocks of them too. Each SLS unit costs about $10 billion each, which is quite expensive compared to the cost of the Falcon Heavy and Starlink that SpaceX is providing. So here is a timeline of what Artemis is planning to do. So you see here they're planning to create another, basically ISS, on the moon. And basically, what I mean by ISS is the Deep Space Gateway. And the Deep Space Gateway would be floating around on the moon and would just orbit it. And it's basically like an ISS except on like orbiting the moon instead of Earth. And there have been plans already made on how to create it, and specifically plans on which space agency will do what in creating the Deep Space Gateway. And they have dedicated near $333 million into the Deep Space Gateway. Now, they're planning on having mobility rovers and creating civilizations on the moon with this program, along with even ways to keep the civilization self-sustaining and not just we're just sending resources over to them. Like there has been a possible concept of harvesting helium and hydrogen from the moon dust to create fuel and blast rockets off. So there have been a lot of suggested things to do for Artemis. And not only is Artemis headed for the moon, Artemis is also headed for Mars. They're planning on not just Mars, but even further and to interstellar travel and terrestrialization of the planets beyond Earth. Interstellar travel for humans. So here are the 4 targets of the Artemis program, the future Artemis program. They include going to the moon, and it's to send the astronauts back to the moon from, it has been near 50 years since, near 50 years since the last Apollo program has sent people to the moon. So it has been a long time since we actually sent anything to the moon. So they're planning on sending people back to the moon, and we're also going for Mars, and it's a goal that will never fail. And pretty much since we discovered Mars, we wanted to go there, pretty much as just like any other planet. And in deep space is human terrestrialization. I always get this word confused. Human terrestrialization of deep space is one of the goals, not just on staying on planets, but also in space, because we need to learn how to help astronauts survive the radiation of outer space and and have materials that can stand the micrometeorites of outer space, and also how to protect themselves and especially patch up the holes if there's emergencies, and especially help people on Earth with technology that has been researched for space uses. Here we go. Rockets and how they work by the phone.
Okay, here we go. Next slide. Okay, so we really need to know about how rockets work if we're going to talk about rockets themselves. And so these are actual formulas that NASA uses for their rockets. As you can see, there are words that tell you what each like equation means, and this is all leading up to the ideal rocket equation, the second equation. And so you can see that it does look very complicated, and it kind of is. It's not too easy to consider all of these variables, but it's actually not that hard to um calculate all this, since it's just basic arithmetic. And so here the first equation is the final mass of something is equal to the mass of an empty rocket, because this is trying to say that the final rocket is always going to have no fuel, just like if a rocket has no fuel in the beginning. The next one is the ideal rocket equation, which is basically telling you the delta U equals the velocity in um, like mass, final mass over mass empty. And then like these are, I'm not gonna explain every equation, but these are all some that show you how to calculate rocket things that are related to rockets. The last one is about considering how gravity would impact everything. The third last one is about ver- like considering velocity, and the fourth last one is like exit velocity for exiting the atmosphere. And the second to last one is considering how much propellant you require to perform a maneuver and stuff like that. The third one itself is just substituting mass propellant ratios so that you know how much propellant you have to go on with the mission. So now gravity assist missions. Okay, so gravity assist is the use of another object's gravity to get faster in space travel, and that is one way that rockets are launched, and this is how most interstellar travel works today, as all rockets have either slingshotted or used gravity assist from other uh, planets to do this. So I'll begin with what slingshot are. A slingshot is when a um, rocket is put into the orbit of the Earth or whatever object it has launched off from. Then it adds power to its orbit with burns that are sequenced near every half orbit. And so that makes the slingshot longer, 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 and faster. Eventually, they complete the burn and they get ejected from all gravitational influences of the planet. This allows them to leave to interstellar distances. And then they course correct themselves to where they need to go using RCS, remote control system, or some other small propellants. Gravity assist missions are very similar, except they don't require to be launched at the object they're orbiting. They just go to an object and then go around them, and then going around that object will give them additional speed. And okay, and then now the Voyager and Mariner programs. So the Voyager program only consisted of 2 rockets, and the Mariner program consisted of 10. But they have striking similarities, as both of them were made to go beyond Earth, except one rocket. So Voyager 1 was the first launch in the Voyager program. It went in a different direction than Voyager 2 so that more of space could be mapped. In the same way, Curiosity, Perseverance, Ingenuity, and Opportunity were all launched to different places on Mars so that they would never meet and map the same places. Yep, next slide. Okay, so now this is a timeline of what happened in the Voyager program. So as you can see, they were sent in different directions. Voyager 1 going out, um, for us that would be west, and Voyager 2 went somewhere southwest. They both used gravity assists. As you can see, they started underneath Jupiter, which is the 4 main bodies of the solar system that are rocky planets. And so they both took gravity slingshots from Jupiter and Saturn, as you can see, small nodes. but Voyager 2 took a slingshot from Uranus and Neptune after Jupiter and Saturn. So Voyager 2 and Voyager 1 were were sent into space pretty fast because of how many gravity assists they took. In on March 5, 1979, Voyager makes its closest approach to Jupiter, and by August 25, Voyager 2 flies by Saturn. And then in July 9th of 1975, Voyager 2 also makes its closest approach to Jupiter. Um, in August 25, Voyager 2 makes its small closest approach to Neptune to observe Neptune. And you can also see in the other corner that they also went into other directions as well. So there were three phases called bow shock, heliophase, and terminal shock. Terminal shock is just leaving the influence of the solar system. Helio oh, heliopause is making sure that the sun has no gravitational exertions against either. And then bow shock is leaving complete premises of anything solar system related. Yep. And then these are the Mariner spacecraft. So the Mariner spacecrafts got bigger and bigger over time as they needed to get more complicated, but most of them had satellite dishes, as you can see, and those were to communicate back information. They all had solar panels so that they could run forever, or at least almost forever. And they all had instruments. You can't see it, but they did. The instruments included UV cameras to temperature sensors, all kinds of things to help them observe planets in the solar system. Next slide. And so this is what planets they each went to. Mariner 10 made it to Mercury and Venus. They weren't two Mariner 10s, but in fact, Mariner 10 was one of the first spacecraft to do a flyby of two, like a multi-planetary flyby. They it went past Venus and then flew past Mercury right after that. Mariner 8 failed, crashing back into the Atlantic Ocean shortly after it launched. Mariner 1 and Mariner 2 flew by Venus. Mariner 5 also flew by Venus. And most Mariners went by Mars. Mariner 3, Mariner 4, Mariner 6, 7, and 9 all went by Mars. None of them made it to the gassy planets, as that would have taken much more fuel and power to take them there. So they were going slightly low on budget. So that's why the Mariners didn't go far. They only went to the rocky planets. Now here's some fun facts. So does anyone know about the golden records on Voyager 1 and 2? Well, the golden records were like records consisting of 55 noises from Earth, lots of songs, lots of voices, laughing, hello in like 9 million languages, and stuff like that. So it was just to make sure that, like, if somebody somehow finds the spacecraft, they would kind of know what humans were if they were able to play the records. But turns out record players weren't set on either spacecraft, so they would have to invent the record player if they wanted to know what was inside. Huh? Not too convenient, NASA. Well, next is multiplanetary flyby. Like I said, Mariner 10 was a multiplanetary flyby. Voyager 3, well, it was supposed to be built, but it actually wasn't. It was cannibalized during construction, used to make a different spacecraft, all of its components. Mariner 1 through 10, Mariner actually means sailor. Mariner comes from marine. So it could have been named Sailor 1 to 10. Mariner 3 and 8 were failures. Mariner 3 actually did fly by something. It's just it was unable to do much since it ran out of battery, well, electricity, and it had a separation issue.
So that's all for this webinar. Do we have any questions?
Okay, how about what was the most expensive project?
I would say the Apollo program.
Yeah, Apollo.
$250 billion.
What was the shortest mission?
What?
I'd say Voyager. I mean, like, you mean like lasting or?
Yeah, shortest lasting.
Okay. It might be the
I took a break from webinars for like, I'm like,
3 weeks.
who's host? Who was host? Don't start this. Don't start this war. You don't want to.
Oh, you want to know who's host?
Who's
I will
host?
tell you. Right now, that would be Chemical 3, which is Vera.
Oh,
Are
Vera.
you
Oh,
I'm
oh wait,
also-
never mind. It's Vivat and Vera.
Oh, you guys want to
And me.
You guys
And
want
No,
But you
no.
can't really demote
You guys want to?
True.
Okay, okay. No. Not.
Everyone
not-
host. Every
That's
give
what I
every.
thought.
Let's get back to questions.
Okay.
So, that was interesting. Anyways,
Do you guys think a close to light speed engine actually exists?
no.
So why don't
Not
like
yet.
I've been waiting to ask this question. Like, why don't those like rocket engines, like, how do they survive that temperature of heat?
Oh, I literally watched a video on that. There's methods.
They don't. It's
On-
just they expel gas that is that temperature.
No, look, I will show you this. I'll just show you this image. It should do the trick. That explained to you.
Oh wow.
Yeah,
And now
no.
we have.
Yeah, no.
First sent me hello stranger. You know what I said?
Wait, why do we have?
Oh, somebody has closed captions.
Yeah, I know.
What?
Okay.
Yeah, we want our engines to melt. We do.
Oh boy. You guys want me to unmute this?
Asian dads.
Can you guys hear it?
Yeah.
Huh?
I can hear it.
I can like barely hear it.
Which takes the heat along with it. It's most commonly made out of carbon at a very high altitude. Also, the same principle is used on their heat shields.
Okay. Let's get back to the webinar.
Yep, back to the webinar.
Yeah. So yeah, that does make sense. And it's a curved surface, so it bounces off much easier than most of the other surfaces.
They also use rare metals to keep it from,
Yeah. What would you say had the most?
It's ridiculous that they're 3D printing rocket engines. I mean, how does that work? 3D printing rockets.
Yeah, I found that quite ridiculous. I heard of it.
It can only
What do you
fit-
think would be the most like publicly approved of, like by the community?
What do you mean? What would be most publicly approved?
Starship.
Like, what does the community like the most out of those machines? I mean, like, it might be the Starship. It could be the Starlink program or Polaris.
But I have one thing to reply.
It's definitely not Artemis.
It has to be Artemis.
It's definitely not Artemis. Not a lot of people believe in Artemis. It's like
Although maybe they even made a
yeah.
or something.
I mean, they had like a lot of support toward Apollo, and they really believed that they could get past the
well, I
space
think-
race thanks to John F.
I guess
Kennedy.
US was lying about the new light speed engine. Here's the thing. What's this?
There's a golden raisin out of so many purple raisins. Confusing.
That's also not helpful.
Do you guys think you would be able to manage being in charge of creating a light speed engine?
No,
I know.
it's not even possible. You can't go faster than the speed of light.
No, not faster, as fast.
Well,
That would
that's
kill a
not
human.
possible either.
That would definitely kill a human.
You could go 99.9999% the speed of light, but you can't.
Well, you
ever
can't. Well,
reach
think.
light.
Well, if you get hit by something at the speed of light, you won't actually die.
So if
I mean,
you're driving a
literally, if you
spaceship that
get
goes the
hit
speed
by a
of light,
leaf
you'll
by
die.
at the speed of light, you'd probably die, right?
No, you can't die when like you're not gonna die when something hits you at the speed of light. I'm
Because-
literally getting hit by the speed of light right now. and I'm not
Exactly.
dead.
Yeah. So
How
nothing.
about an object moving at the speed of light, though? That's
Nothing.
No,
Nothing.
guys.
So are you saying that
think about,
particles are not objects?
think about
Oh,
G-force.
that is true.
Imagine the forces they'll be experiencing when they go speed of light. They'll just crash back into their seats and die.
Their body could probably warp.
Actually, first of all, they wouldn't warp. They'd probably go back in time or die.
Oh, wait, let me just search up a movie clip
Back
for
in
that.
time, back in time.
I'm just gonna
Or probably not back in time, probably into the future, not back in time. Wait, did you know that Starship promises a less than 1 hour trip to any place on Earth?
Sure. Let me take it.
True.
Let's take us to the Himalayas. Oh wait, there's no launch pad or landing pads.
No, wait,
We all
I
love.
have a great idea. Why don't I move 1 meter with the Starship?
1 meter. Too much fast through.
How much fuel would that waste?
Oh, guys,
Yeah.
the hosts can hosts edit the meeting controls?
Okay.
Just wondering, can they edit the meeting controls?
Sure. Yes. Now. Do whatever.
Okay. We got the Q&A over here. How do we ask questions? There's no ask questions.
I have to go because I'm going somewhere.
Okay.
Yeah, I'm at with you.
Bye.
So is that all for this webinar?
Yeah, I guess that's all.
Okay.
But before we all go, everyone go to video filters and choose aerospace goggles.
No.
Yes.
No. So that was all for this webinar, and you can stay back for if you want to have the
3,
panelists choose the topic.
2,
And that was
No,
all.
no, Vish, don't leave. Vish.
no. Oh, come on,
Could
blast
stop the-
off.
Could you stop the live stream?
Okay, I'll try to stop the. Oh,
You can't. I can.
someone